I think we can start. Let's have a signal that we are online. Perfect. Hello, everyone. Welcome on the next AWS User Group in Krakow. Today we are in a new place, and we have a few new guests. Today on stage, Dominic will help me with the introductions. He is also an AWS leader, but from different city actually, from Dublin. So that's a great visitor as well. But we are here actually to have great presentations from our guests today. So let's start. I think we can say also that we will have some quite interesting information during the session, so pay attention. And on the side, you can also use the vouchers for beers or for other drinks if you want. And there will be also a quiz, so you can win a prize.
Hello everyone, thank you for the invitation. And I encourage you to stay at the end of the event because we will have a great announcement. So keep in touch and stay at the end of our meeting. Right now, I think we can pass both to our guests, our presenters.
Yeah, so we can start. The mic is yours.
Thank you.
Thank you, guys. Thank you all for coming. Not that many people I see, but hopefully there are more people watching us online. Thank you for your time, and hopefully we will have an interesting story today. We call our presentation PK, Next Step the Revolution. There are two reasons why we call it like this. First of all, cloud computing brought a drastic change to how you can run IT for your business. We could not imagine 10 years ago that you can do all these magic digital things that fast with your technologies nowadays is possible. So it's a real revolution. And second, the reason is because when we started the journey, we were really scared. And looking at the list of applications in our portfolio that we had to migrate, we believed that was mission impossible. You know that movie, where in that movie, the hero of Tom Cruise always managed somehow to accomplish the mission. And we believe that we do the same in this journey. So let the show begin. Agenda. Today we will try to, first of all, we will explain who we are, what is our company about. Then we will try to explain how did we come to this roadmap and actually started the journey. Then I will pass the voice to Robin, and Robin explain the specifics of the migration of migrating one Salesforce automation application, or it's better to say family of applications into cloud, because we are talking about 42 different instances of the same application used by more than 60 markets, and we are quite well in progress. We will describe the approach, we will tell you the benefits that we got out of this migration. Of course, we will present some lessons learned and challenges that we faced during our journey. And at the end of this session, we will be able to ask questions, if time permits. So, what are we? Who are we? My name is 𝐿ę𝐝𝐳𝐲𝐦𝐴. I'm manager at Cloud Migration, and I'm taking care about one of the squads inside the cloud migration program that is taking care about migrating applications, SFA applications into cloud. As I said, 42 different instances used by multiple markets. I'm in IT for 25 years and 20 years with PMI. Started as an analyst programmer back to 2001, so quite a long journey. And at the time, the cloud worked like only something that produces rain and covers the sun. Nowadays, cloud work means a bit different. You can also scan QR code and see my LinkedIn profile. Robin?
Thank you, Alexei, and good evening, everyone. A quick brief introduction about me. I'm Robin Blaria. I'm working as lead software engineer in PMI. I started my journey in PMI back in November 2020. I have overall 10 years of experience in IT, and before joining PMI, I was working as a software developer in AWS Limited. Yeah, so I'm AWS Cloud Practitioner certified. I'm DevOps Foundation certified, and if you want to, if you need more details about my profile, you can scan the QR code. So let's see. Back to you.
Thanks, Robin. Before we start, a few words about our company. 𝐿𝐴𝐴𝐽𝐽. Of course, many of you heard about 𝐿𝐴𝐴𝐽𝐽, right? These days, everyone knows 𝐒𝐲𝐴𝐽𝐽. And there are other famous products of our company that you are aware of. And we are working in the IT department of 𝐿𝐴𝐴𝐽𝐽 here in Krakow, IT hub, in my shared service center in Europe. And our company is an international company. We are located in multiple locations, more than 180 locations across the globe. We have more than around 71,000 employees across the globe. We are #1 company in Poland and the global scale, certified for equal salary. More than 300 employees working here in Krakow in IT. More than 20 different 33% of women in our department, and this is something we are proud of. And of course, we have multiple departments, 9 departments actually here, and among those, artificial intelligence, big data, service management, product teams, and others. Join us. You can scan the QR code and see more details about our company. So let me start maybe from the road. How did we come to the decision that we want to go to public cloud? The future is in cloud. On-premise is dead. As you can see, the store is destroying the hardware, the bare bone hardware, because public cloud, this is the future. Of course, this is not the first time we started using AWS or any other cloud solutions. Previously, we were sporadically or for some specific cases using AWS, specifically for our digital platforms, or experimenting with some edge technologies. But we even built on-prem private cloud because we understood that this is the best way to go when you can ramp up the environment in minutes, not in hours, and avoid all these lead times waiting for hardware to be delivered. But then the decision, the understanding has come that we need to go to public cloud. Why? There are a few reasons. Reason number 1, we are a tobacco company. We are producing tobacco products, right? And we cannot compete with all these cloud providers that provide all this edge technology that we want to leverage, we want to use in our digital journey, but at the same time, as I said, we will hardly be able to compete with this. Second reason, why should we invest and constantly upgrade our hardware? It's outdated in a couple of years. Instead, it's better to invest in something that makes sense, right? And the decision has been taken actually to leverage all this public cloud capability, all the edge technologies available in public cloud, and the journey started back in 2020. As you can see also on this slide, the journey is quite complex because we have 2 data centers in Switzerland with something and our journey scopes to migrate all applications from all these on-prem locations into cloud. How can we do this? When we started the journey or decided to start the journey, of course we understood that all applications should be migrated and fully operational in cloud, with minimum impact on our business and ensuring that performance of this application is better, the leverage of the technologies available in cloud. But at the time, we didn't have full understanding how many applications do we have. Of course, we knew the global portfolio, the list of applications in the global portfolio. We knew some local applications that existed on market, but still market by market, there are some local specifics there are local legislation requirements, and many markets build their own features, their own applications that the central team was not aware of either. So we decided to start this inventorizing, actually trying to understand what do we have. We spent some time and ended up with a list of all applications that we might own across the globe. As you can see, 2,300 plus, a lot, quite a lot. Then we looked into this list and tried to understand what can we do with this, because it was not feasible to start migrating all this application into cloud just all of a sudden. Looking each and every application in the list, we tried to map the application lifecycle, the roadmap, and understand what is the functionality the application provides. End of the day, some of the applications were considered as legacy and retired. Some of the applications were recognized as duplicating functionality. And we decided to consolidate them in one global application that reduced the number, right? And of course, we end up with some of the list of applications that we cannot avoid but to migrate, because this is the core set of solutions that our company resides in. End of the day, we had around 700 applications that we agreed to migrate into cloud. So the scope is clear. How to migrate? The team, which we call CTP, or Cloud Transformation Program, has been assembled back to 2020 and started the POC. We tried to validate certain assumptions, certain technologies that we can use to migrate applications from on-prem to cloud. And once we understood it's possible, the whole program started. The whole program started in 2021, and actually we had 2 years, only 2 years to migrate all these applications into cloud. Because end of 22, end of this year, we have a very hard deadline to close our Swiss data centers with all these 4,000 servers, and majority of our applications are living in 3 data centers. So the journey started. Last but not least, we also organized a new team, new support team, which we call hyper-productive run, because the cloud operations is different from how you support or maintain applications on-prem. Different capability, different skills are required. Second, as I said, there were quite a lot of local applications designed on the market, supported locally by the markets. And after the migration, all these local applications were handed over to the central team with the idea to free up the local resources for more added value activities, not to spend these many days on supporting application, but instead invest in something that really help us to earn money. That's why we organized the hyper-product run team, which actually is the external partner, as you can see on the slide, while the product team, while all employees were relocated to added value activities, and we're taking care about building roadmaps, designing new features, and actually building the future of the company. A typical journey to cloud, how does it look like? It consists of few phases, 4 phases. We start with kickoff, right, with some lead time before we start the discovery. The idea is to communicate with our stakeholders, with our business owners, and to explain what does it mean migrating to cloud. Present very high-level schedule, reserve the resources, and agree on the KPIs that we will follow during the migration. Once kickoff session is finished and the scheduled markets are ready for the migration, we start the discovery session. Discovery is a very important phase, because during the discovery we try to understand what are the applications about. We begin into each and every detail of the applications that are being migrated. For some applications that are global, a central team knew lots of things, and that was easy work. But for some applications that were designed to build locally, we had to spend quite a lot of time to understand the essence, all the details, all the integrations, etc., etc. End of discovery, the outcome of discovery was a set of documents that actually describe how application behaves, what is the on-prem architecture, how the architecture in cloud will look like, and what is more important, all these designs are validated by our technical stakeholders. By technical stakeholders, I mean our security team, our integration team, our performance and testing team, and of course we engage running support team. so that during the handover, later after the go live, we don't have any surprises. Once we have our designs approved, we start the migration. Actually, migration itself, once the architecture is done, is not rocket science. It's easy thing to accomplish, but at the end of the migration phase, we approach testing. And this is where the beauty starts. To improve whatever actually is delivered in cloud, we go through a few cycles. First of all, we do disaster recovery testing to be sure that if application in cloud fails, we can restore it in an automatic way, fast, and that corresponds to the assigned SLAs. Second, we do performance testing. One of our commitment in front of the market during the kickoff session was to ensure that application after migrating to cloud perform at least the same as on-prem or better. And in all the cases, we try to ensure this. Last but not least, we do integration testing and approach local business users to do the UAT, user acceptance testing. Once UAT is finished and we have a green light for go live, we do the cutover. Normally, typically cutover we run over weekend. We start it on Friday evening and open the application on the Monday morning, so that the implication of the business operation is minimal. Once application goes live in cloud, we have hypercare. Typically, it's 2 weeks, during which we closely monitor the application. We try to resolve the bugs, anything that happens abnormally, if any. And once hypercare finishes, we transfer the application into hyperproductive run support to this newly established cloud operations team. Next is deep. Of course, migrating to cloud looks simple, right? And as I said previously, we use AWS to migrate few applications, not to migrate, to design, develop few applications fully cloud-based, like our digital platforms, but we never used cloud infrastructure to host 500 or 700 applications, quite a lot. That's why we start thinking how we can manage this. And we decided to build a platform that will enable lots of supporting services around AWS account. That will help us, first of all, to ensure that a user can request or a product team can request an account in a self-service manner. So we created a self-service portal. Second, we created lots of supporting tenants, we call it tenants, that ensure all the supporting stack around the application. It's CI/CD pipelines, it's monitoring, it's Terraform through which we can deliver infrastructure as a code. It's a set of security tools that are embedded into our pipelines and scan the code. It's security tools that scan our infrastructure constantly, on a regular basis, and report anything that is abnormal. Does it not look like a revolution? Deep changes everything. The famous slide where you can see that previously, when we used infrastructure on-prem, that was taken as months. If you want to build a new application, you need to take into consideration certain lead times. You need to have budget, you need to require to secure, you need to purchase hardware, you need to wait until this hardware delivered, then you need to wait until infrastructure team set up this hardware, installs operating systems, installs databases, whatever. And only after that, the development team was able to start actually developing the application. Nowadays, with this platform, this is quite fast. Still, you need to have the budget, right? But you can request an account in the self-service portal and get the whole infrastructure delivered for you in hours, sometimes days. Depends on the complexity of the application and the complexity of the number of tenants that you request. This is really sounds like a revolution, does it not? Well, I don't want to spend your time more on this generic topic. There was a good meetup 2 months ago made by Piotr Kondratovich, and he touched this topic about the cloud migration journey, about deep platform in very good details, so that if you want to watch it, just scan this QR code and enjoy. But now let's come to our story about ISMS application that we have migrated into cloud. And I pass my voice to Robin who actually leads software engineering in my team and did this magic by his hands.
Thank you, Alexi. And once again, good evening, everyone. Today, I'll walk you through our journey of migrating one of PMI's SFA application to AWS Cloud. Okay, so I'll touch upon the migration approach that we followed. What are the key takeaways from our migration to AWS Cloud? What are the benefits both for IT and the business? And what are the key challenges that we faced during the migration? And what are the lessons learned about from our migration? Okay. So what is this SFA application that we are migrating to cloud? So our SFA application is known as ISMS. It stands for Sales and Merchandising System. The application itself is used by more than 60 PMI affiliates across the globe, and it's used both by the back office users, and we also have field force users usually who go to the fields and they perform their regular activities. Yeah. So the application is built on the AWS architecture. It has a client application, it has a server, it has a database. And when I'm saying ISMS application, just to give you an overview of the complexity of the application, when I'm saying that ISMS application is not just one application. Okay, so we have around 32 different ISMS instances, which means that the application is, every market or every country, they have their own instance of the application. Yeah, and we have around 10,000 field force users across the globe. There are 2,000 back office users. The application itself has integration with data warehouse solutions, SAP ERP, and other finance applications. So, just a few other facts about the underlying hardware of the application or underlying infrastructure. As I was saying that there are 42 different ISMS instances, meaning we have 42 production instances of the application running in PMI Swiss data centers. And if you multiply by 3, then you can guess the number of instances for the application that are running for dev and QA environment. And then finally, taking all this into consideration, we ended up with around 120 physical servers, around 140 application servers, 140 DB servers. Of course, these are virtual servers, and then we have around 200 SSIS packages for this application. We have integration with 50 data warehouse data warehouse solutions. Okay. When we talk about the platform of the application, then we have around 40 iOS or Android applications. There are 2 laptop versions of the application which used by the field force users, and then of course in Office we have around 42 desktop versions of the application. Now, just to give you an overview of the on-premise infrastructure, so this is what the infrastructure looks like. So don't be scared. This is just to give you a sense how the infrastructure looks like on-premise. So as I was saying, this is a three-tier architecture. We have application service where our main application is hosted. It's based on Microsoft technology stack. It's a .NET application. Then we have client applications, which is there on the Citrix NF servers. So these Citrix NF servers, they are also hosted in Swiss data centers. So users usually they interact with the back office application via the client application published on the Citrix NF servers. And Citrix NF servers we are mostly using, where we have the latency issues, because this application, as I mentioned, right, so it's used by many affiliates across the globe in PMI. So we have affiliates in Latin America region, we have affiliates in Asia Pacific region, and there we really experience latency with the application, and that's why we have a server where client application was hosted. But if you talk about the European region, then there are some cases where the client is hosted on users' laptops. Okay? Now, so we also have mobile application, which usually interacts with the back office applications, and this mobile application is used by the field force users. So in the morning, they come to office, they take their data from ISMS office application, then they go to field, perform their journeys, and then they come back to, in the evening, they come back to office, and then we exchange or synchronize their data back to the main application. And this integration, it is mostly based on the flat files. Yeah, so we have SFTP server in between this mobile application and the ISMS back office main application. And why we have this mobile application? Because initially, when the application was built back in 2006, it was supposed to work in a disconnected mode, right? So at that time, we didn't have that much fast internet. So the application was designed in such a way that we do not have internet facilities. We are also field force users. They can work with the application, perform their jobs. So we also, as I mentioned previously, we also have integration with data warehouse solutions and reporting solutions. We have integration with SAP. There are some other third-party apps where we are kind of exchanging data. It can be master data for reporting purposes. Okay. So moving on to the next slide. Now the migration approach, right? So what sort of strategy that we followed when we kind of started the migration for this particular application. So we kind of explored different possible migration paths for this SAP application, and of course one is the best path to go for is refactor, right? So if we can kind of modernize the application to cloud native, we can refactor the applications to make them more cloud native, but refactoring the application, it requires, of course, efforts and time, right? So if we have time constraint and we have a hard deadline, then definitely we cannot refactor everything. Yeah. So this is one of the options that we explored. Then another option was repurchase or replace, right? So completely replace this application with some other latest solution that is available in the market. But then there are some other considerations that should be taken care of. For example, in the market, another solution with a similar functionality should be available, right? So business should be ready to take on board this new solution. Then another migration strategy was to re-platform, right? So wherever it's possible, just use the AWS resources without any major change into the technology stack or without refactoring the code. And then, of course, last of course, rehost. So, of course, it's a dirty approach. So you just lift and shift your workloads to AWS cloud. So we kind of explored and went through all these options, and finally, at the end, we kind of selected the hybrid approach, right? So we decided on that. For the components, we host. So we go with that, and wherever it's possible, we refactor the code. Okay, so what does it mean when we say that we went ahead with the hybrid migration approach? So when we started the migration, we kind of looked into each and individual component of the application. Okay, so we decided that, or we kind of figured out what can be done with this particular component. For example, this remote access. So, can this be refactored? Can this be rehosted or re-platformed, right? So, we finally ended up with that. Okay, this can be refactored. On-premise, it was most application surface. So this is the main ISMS application where most of the workload resides. Okay? And the application has been changed a lot over the course of time. Different functionalities have been built over the course of time, and it was very challenged to change this and refactor this to microservices architecture. So we decided that within the timeline that we have, we won't be able to refactor. So we decided that let's go ahead with the rehost, and we rehosted this on the AWS EC2 or Windows Server. Then we data transfer tool. This is also one of the small application tool that is a part of our application, and this tool it doesn't kind of perform any business operations, right? So this tool it sits between the mobile application and data copies application, and it's just convert the flat files which are generated by data copies to the mobile application compatible mode, right? So if we have the iOS application, then this would be convert the files into the SQLite databases. So, as I mentioned, there is no functionality involved, so it was easier to refactor this code, and we kind of refactored this into, ECS task, and the refactoring it was done in such a way that this application it won't be used only just for the one application instance. That the strategy behind was that we will be reusing this for all other applications that we have in the migration roadmap. Okay, without any refactoring. Then in the database. So on-premise we have ISMS SQL 2012. Our database is posted on the SQL 2012. And when we migrated to cloud, we decided that let's refactor it to RDS, AWS RDS, MS SQL Server. And we also have the option to go for MS SQL Server on EC2, but then we finally decided that okay, we do not want to manage the EC2 instances. We do not want to do the patching. We do not want to do all the maintenance activities for the database. So we went with the AWS RDS, which is the database, and then we don't have to kind of think about all the patching and the maintenance activities. And this is one of the reasons why we went with the AWS RDS for hosting the database. Then we have the integration services. Okay, so initially when we built our pipeline or the baseline, we decided that for databases we will go with the RDS. Okay, so there won't be any MS SQL Server on the EC2 instances, but in the middle of migration for one of the market, we found that there are some SSIS packages which are built by local market, and the central team or the migration team, they were not aware of these packages. Okay, so then finally we can explore the option how this can be migrated to cloud. the package it has certain features, certain script tasks which are not compatible with the idea, and then we have to sort of deviate from our baseline. We have to provision an SQL instance and an SQL server on top of that, so that these SSIS packages can be hosted there, and they can still continue to work. But having said that, in the approach that we followed, we won't be provisioning a new EC2 instance for each and every market. Okay, so wherever we have these SSIS packages, we will be hosting this SSIS package on the same EC2 instances, so that we can reduce the cost. And the important factor here is that that we must have a situation where we are kind of hosting the components for different applications on the same instance. We have to consider that what sort of data these SSIS packages are processing. Okay. Then another component was integration with the Active Directory. So on-premise, we were using this LDAP query for the authentication for our application, but when we migrated to cloud, we built NEC service, which is using the MS Graph API for public authentication of our service. Then the integration, which is based on the stack files with the third-party system. Okay, so on the on-premise, the integration mostly was based on the SFTP server, but when we migrated the application to cloud, we decided that we will go for the AWS. So this is exactly what we meant by hybrid approach for our cloud migration. Now, just a quick look at the infrastructure, what we have on-premise and what we ended up when we migrated the application to AWS Cloud, right? So the picture, it might not be clear, it might not be clear for you guys, but this is just to give you a sense, what we have on the on-premise and finally what we have on AWS. And of course, there are some important considerations that we agreed on. We modernize or we refactor the application wherever it is possible. Wherever it's not possible, we simply rehost the application on the cloud. Another important point that we do not change the functionality of the application. We keep the functionality intact so that we do not have any surprise issues when we perform the UAT or perform the testing. Another point, we try to ensure that the performance of the application improves in the cloud, or at least the performance it should not be based than what we have on the on-premise. Okay, so a quick look at the ISMS Migration Roadmap. So, when we started this journey back in January 2021 for this particular application, we know the workload that we have. That we have 40 applications. Okay, and we know that there is a strict deadline that at the end of 2022 we have to complete the migration. There is no extension, right? So if we don't complete the migration, there is a scope that few applications they might be retired after 2022. So initially, yes, definitely we were scared whether we will be able to achieve that deadline or not, because we were new to this cloud world, right? So what we did in the beginning, that we took few of the markets into the pilot, right? So we started the pilot with 3 markets. It took us around 6 months to complete the migration for the 3 markets. Why it took us 6 months? Because during this pilot, we tried to build the baseline, architectural baseline. Okay? We tried to define the security patterns. We tried to define the testing baseline. Okay, so as I mentioned, we have 42 different applications, but the core, the core infrastructure or core technology stack for this application remains the same. Okay, so 90% of the technology stack is same for all these 42 applications. You might have some variations here and there, but most of the things they remain same. That's why we kind of build the baseline that can be reused for other future migrations. So when we, in the Q3 last year, when we started the migration for desktop applications, we could go more aggressively as we already have the baseline ready and market, and that gave us the opportunity to speed up the things. And by end of Q3, I can say that we already have 23 application migrated. Now we have around 8 markets which are still to go live on the cloud, but we are confident enough that we will achieve the migration for these applications within the timeline that we have. Now, what are the key important takeaways from our migration? So we have built and pre-approved the architecture, testing, and security baselines that are heavily reused once we have approached each and every next market. We have built the technical library of the architectural patterns that can be used or shared among other squads within the CTD program, and sometimes we also take the help from other squad to speed up the things. So with this migration, now we have become a team of cloud experts that trust each other, are trusted by our stakeholders, and we are confident in what we are doing, and we have done that successfully for 25 markets. Also, we ensure that application works faster in cloud so that we can pass on the real benefits to our customers and stakeholders, and that also kind of increase the confidence of the next scheduled market. So whenever we approach another market, that okay, so we will start the migration for you, then we share the success story from the previous market, and this provides them the confidence that everything will be working fine once we move the solution to the cloud. So we are also in good cooperation with our team. So we onboard the team during our migration journey. So that the support team, we are also aware of architectural patterns, what we are doing in the solution to the cloud, so that it will be easier for them to support the application once it's already live and part of the runtime. Now, what are the benefits? What are the benefits of migrating the application to AWS cloud? Why we are migrating the application, right? So benefits, it can be both for IT, and it can be benefits for the business as well. So for the IT, one of the benefits is that we can remove the burden from the IT team to deal with the infrastructure. As you know, maintaining the data center, managing the server racks, everything, it requires a lot of effort from a lot of people, right? And as Alexi was saying, that we are not in the business of maintaining the data centers. We are a cost-saving company, and that's why we wanted to outsource hardware maintenance to a cloud provider. And here in our case, it's Amazon. Yeah, so that people in our company, they can focus more on other activities, which brings more value to the company and the business. Then it's easier for people to provision new hardware infrastructure as the infrastructure we can deploy as a code. We just write a piece of code, and the infrastructure will be provisioned. Okay. Then there are benefits in terms of scalability, elasticity, and flexibility. So we can easily adapt to the business requirement, and we can react to the changes in the organization very quickly. Now, benefits for the business. Of course, business key stakeholders, they do not care about the underlying, or they are not interested in the underlying, servers, data centers, RAM, hard disk, right? So for them, application should work and it should work without any outage, right? So, but there are, when we migrate application to cloud, there are the benefits for the business as well. For example, with all the monitoring that we have in the cloud, all the automated recovery procedures that we have in the cloud, we can minimize the outages of the application, and we can improve the SLA of the business. And then, of course, the business has agility. So, on the on-premise infrastructure, and on the on-premise platforms, yeah. So, whenever business they require to onboard a new functionality, yeah. So first we kind of do an analysis, what sort of hardware resources we need, and then we make a request. The request will be approved by some person. Then once the request is approved, someone has to, go and purchase the hardware, go to the data center, fix the hardware, and as you can imagine, how long it will take to, provision the infrastructure. But with the cloud, whenever business requires a new feature, they can just request, and the infrastructure will be deployed within minutes rather than weeks. Yeah. So then, of course, there are the benefits in terms of the user experience, because the application will work faster in cloud. We can optimize the cost as well, as we will, we can shut down the unused resources in the cloud. So moving on to the next slide. So the challenges and the lesson learned that we have from our experience in the cloud. So one of the learning that we have, from our experience, is related to the cloud, because cloud is related to the cost, right? Because cost is an important factor for any migration or for any of the project. And if you do not kind of monitor or manage your cost on the AWS, efficiency will go down. So we kind of stress on this, that right side your AWS resources. Always set the monitoring for AWS resource utilization. Do not ignore the recommendations from the AWS trusted advisors. Always go and check your AWS Cost Explorer builds, right? So that you can have an idea which component of the application or which services is contributing more to the cost. And in the end, definitely do not forget to switch off or shut down your resources in ∇and cloud, ∇and Q environment. Then changes in progress. Always finish prior to the migration start. If that's not possible, just freeze in there, right? So no changes will run in parallel to the migration, and you can proceed with the changes after the migration is completed. Okay. Then the client virtualization. It might not be the valid case for your application, might be specific to our applications, but in case where you have an application, there is a thick client, a background client that requires virtualization. Just think about export option to refactor the client, or if it's not possible, just to look for alternate cost-effective solution that works in cloud. For example, you can close that client in AWS upstream. That's the integration. So this is also one of the important factors. Try to build an inventory of all the integrations that you have during the discovery phase itself. Try to onboard the resources for these interface applications, so that when you approach for the UAT, you have the resources already onboarded. You will be performing the UAT for this particular interface. Otherwise, you might end up in a situation that there is no one to validate this particular interface. Then, of course, the security findings. So try to validate your architecture with your security representative. Yeah. So run the security scans, fix whatever the risks are. Those are discovered, and if there is a kind of time constraint, and if a risk still existing on premise and is not high critical risk, so put that risk into the technical debt, and then you can pass on that to the runtime. And then in the last, unforeseen challenges. Okay, so this you cannot avoid. Okay, so but don't be scared. Stay calm. You will always face this particular challenge, but with all the experience that you have, you will be able to handle the situation. Yeah, so that's it from my side. So thank you, everyone.
Thank you. Time for Q&A, right?
So thanks very much for the presentation. Let's check if we have some questions, maybe also online. So do we have a question? Yes, we have. Perfect.
Hello, guys. Really good presentation, and I really like the way you are presenting what you rehost and or take a different approach. So it's not like a single solution for the application, especially like quite old building, like 3-tier way and hosted on premise. I have another question. When you were like reviewing the application and possible solution, are you also considering the cost and like some potential savings, or is like not considered at all during the migration?
I can take this. Thanks. Good question. No, of course, cost is one of the important factors. And at the very beginning, when we started the pilot, we were looking at the cost, and sometimes at the very beginning, it played the bad game with us because we under-provisioned our instances and we had some performance issues. Then we understood, and we even designed the cost policy for our run team that has a step-by-step instruction how actually you should monitor and take which actions you should take after the application goes live. In many cases, we try to over-provision the instance when we go live to ensure that users are happy. But after that, we set up and closely monitor how application behaves. You monitor the tools that AWS provides, and you can clearly see in a week time frame what is under-provisioned, what is over-provisioned, and then you can take respective actions. Is it downsize or upsize the instance? And I can tell you a good story from our first pilot market, when after 1 month of run, we understood that our dev environment costed more or similar as production. And then surprise, when we looked, we understood that there are 2 instances that the team was playing with were not shut down. So yes, cost is very important, and you need always to it's a kind of, in cloud, it's easy to scale up, but it's easy to generate the cost. So you should be careful and always monitor the resources that they fit the need. They don't go beyond. And of course, as Robin mentioned, you can play with shutting down your instances. Prod, non-prod, easy, non-prod, easy, and production instances for some maybe non-critical applications over weekends, for example.
And Piotr, just to complement what Oleksiy said, right? So when we built the pipeline, so we had 3 market in the pilot, okay? And these 3 market, they had the different complexity. So when we approach the next market, the complexity of the market, the application, it differs, okay? So for a few of the applications, we might have different workloads. For a few of the applications, we might have different workloads. So what we decided during this journey that, the market which has less workloads, we will go with the less or reduced instance type for the EC2 and RDS. And this is how we optimize the course over the course of our migration journey.
Okay, thanks a lot. Do we have any other question? We have online, right? So let me check that.
Okay, the question from the audience, the online audience, are you using automation to shut down resources or doing this from the Terraform enterprise resource workspace?
Very good question. Yes, we have scripts, specific scripts designed, and we understood that for non-critical small applications, they should be must do, and instances are shut down beyond working time and over weekends. And if you need that instance to work beyond the scheduled time, you need to raise a ticket. So because there might be some project executed or some other needs, but typically, yes, it's scheduled and they're shut down. For critical applications, we do this yet manually, but still we are working on that, how to automate this, make it in an automated way. But, you know, with critical animals, it's a bit more difficult. So it's in progress.
Yes, that makes sense, definitely. Let me check if there are any other questions. Yeah, I think we are good. So thanks again for your presentation. And before going into the next one, we have some announcements to do. So thanks again, guys. Yeah. So short maintenance break, and we will do some quick announcements.
Yeah. So just quick informations for persons who are in place. So if you have chance to win giveaways from AWS and from Phyllis Morris, so just fill the form. You can see the forum URL in our presentation and also in chat for online guides. So
yeah, thanks for the information. Okay, so I think we can welcome our next guest today, and let's have a short again break for the connection.
Very quickly. Oh, thank you.
Okay, so stage is yours.
Okay, thanks. Thanks, everyone. It's great to be here today. My name is 𝙊𝙚𝙚𝙚. I am.
Sorry, just to make sure that it works. Do you are sharing in the?
Oh, I have to share my screen.
Yeah, you have to share just that we have the online.
Hopefully it's readable. It's not too far away, so that the viewers, if they are online, they can see the screen. And probably there is some delay as well with that. So as you see, I'm 𝙊𝙚𝙚𝙚. I am coming from AWS. I'm a practice manager leading our emerging technology team, which is AI/ML, IoT, and data analytics. We have a quite big team in Poland serving out customers globally. Today, I will be talking about SageMaker, which is a service offered by AWS, which you can train your machine learning models at scale. And we are doing a lot of heavy lifting for you so that you don't need to do setup. And why training large models? As you see that in your pocket, you have a phone 2 years ago, and even now, you compare the hardware is actually doubled amount of memory and disk, and even the chips inside is being doubled. Why? Because application is getting bigger, is getting more complex. There are more machine learning models running on your phone in your pocket that we could have imagined 10 years ago. For that reason, model get bigger every day. And today I will talk about a bit challenges in training large NLP, natural language processing model, and what are the main features of SageMaker model parallel. And I'll talk about our journey, how we actually worked out to train a big model with billions of parameters, and how we can do that quickly, efficiently, cost optimized. Then I will share also some best practice and leave some time at the end for any questions. If you look back over the last few years, models are really getting bigger. As you see that 2017, we had the first transformer model. It was 65 million parameters. And as you see that slowly until 2020, we had a Turing NLG model with 17 billion parameter. But then we see a big shift. We see that there is a GPT-3, 175 billion. We will have Megatron, and then we have a GPT-3 IT. That, as you see, that is a 1 trillion parameters. This is need a huge amount of processing power actually to do all the computation and do this model, do things we couldn't imagine previously do it. So today I will be talking about GPT-3, which is created by OpenAI. It's not an open source. There is a open source version of GPT-3 called GPT-J being released to public that you can actually use it as a business to develop your machine learning model and develop your work on it. So training time for large models takes a lot of time, sometimes months on a big hardwares. And scaling out is critical. So how you train a model quickly, efficiently, and how you have a hardware to optimize that is really critical. For that reason, we need distributed training. In distributed training, we have 2 ways to do that. One is the data. We can create a parallel for our data, how we are spreading out our data across multiple compute instances to train our model. At the same time, so with the data parallelism, you are just splitting your data, the training data, into multiple workers, and the data sits on the multiple workers, and you will get each worker will train a model actually on a subset of your data. But in this case, once we complete, so of course, when you have a data and multiple model, there is a lot of communication between these nodes, between these workers. So that will add the difficulty for actually communication between dependent workers. And this process actually splits until you have a model convergence. So that way, based on your data, you will be getting a batch of the data to train the model, which we typically refer to a mini batch. So with the data parallel, benefits are, it's a simple, it's a scalable, and there is a simple computation and communication overlap that you can actually train your model. But what if this is not enough? But what if I have a model that's really huge, I cannot feed it this way? What alternative I have? I need a large memory. That way, we have a mechanism called model parallelism. In this case, you are actually parallelizing your model, how you are training your models. So that model that don't fit on a single worker, we typically use what's called model parallelism. What is going back? In model parallelism, we have 2 ways to do that. One is pipeline parallelism. So in pipeline parallelism, what did happen that if you look at this picture, imagine is a neural network. You have a multiple layers. So in this case, we have 4 layers. The layers computation actually split based on the layers. So in this case, layer 1 and 2 goes to one GPU. It will do the calculation there. Layer 2 is on layer 3 is on a worker 2, GPU 2, and the layer 3 is the last one is on the worker 3. But if I'm training a model this way, then worker 2 has to wait for worker 1 computation to finish before I can move my computation forward. That way, what we do, we actually add a lot of idle time. So you have resources, you are not using it, and you are paying for it. That way, if you see that when worker 1 passes the information from layer 1 and 2, then it has to wait for the worker 2 and 3 to work until they send the information to the backward pass to get to the GPU 1 or worker 1. That way, you have a lot of idle time. And this is the pipeline idleness is a really huge problem. So you have a GPU is not used. To deal with this, we typically use a technique called microbatching. So we are passing a microbatch of the data through one GPU to do the calculation. So it's sort of we are streaming the data in a fashion, small batch of data goes through so that to reduce the idleness of the GPUs we have. And we basically do a couple of back-to-back independent calculation in order to hide the pipeline bubble. And we call each one of these independent calculation a microbatch. You can see in this example, the arrow shows you which direction the calculation goes. So now, with a model parallelism, second way to do that is tensor parallelism. It just gives you similar effort, but this time we are not splitting based on the layer. We are actually splitting the layers that one layer can be split to multiple parts and be on multiple GPU, the whole pipeline. So in this case, worker 1 have a bit of information from layer 1, 2, 3, and 4, and the rest, they have the same information. So we divide how the data move through the forward pass and backward pass move through the workers in this case. So this is both a big advantage, and it's also a disadvantage for tensor parallelism. On a positive side, we can handle model with a very large layers. As the layers are split across workers, so we no longer need to feed at least a single layer on the worker. But on a negative side, this leads to all-to-all communication pattern between the workers, so that there will be a lot of communication between the workers because they are handling the same layer, and that way there is information flow between the workers. That will add overhead, and is a heavy burden on the GPUs actually. If we see similar example here now, we have in tensor parallelism, we can see that how our model splits between the workers and moving the data, subset of our data into each worker so that they can work as a mini batch. We are sending a mini batch of the data to each workers. And there is also communication between them, how they are communicating. So the benefits here is a fish-large model, or hundreds of layers of deep neural networks, and reduces mini batch size. So you can pass small batches of the data. But there is also a challenge, as I said, that about communication. You need a high bandwidth, a low latency, and difficult to overlap computation and communication. Of course, with a SageMaker, border parallelism is hard because we need to maximize GPU utilization. We need to find a way how we are partitioning our model and our data based on the workers. We also need to manage infrastructure and have a customized training code. This is a lot of overhead if you are developing all the works to create a parallel training. But that's where SageMaker comes in. So you need to have everything from scratch, make sure everything works. But now we make this easy to use. So everything is ready. You just kind of use it for what you need, and it's a sort of pay-as-you-go model. In this case, we have added not just pipeline parallel or tensor parallel, we have added a lot of features to optimize these trainings, how you can build a big model. So pipeline parallel and tensor parallel, I talked about it. Optimize the state sharding is about how we are sharding the optimizer state based on the workers. Activation checkpoint and activation of landing. This is a two-way in neural network. When you are the model do the computation, have a forward pass, then you will have a activation computation. You have the values. This way, you can actually we have developed techniques, part of the SageMaker distributed library, that you can turn an activation checkpoint and offload into true so that you are releasing memories to be used during the training and calculate them during the backward pass. So, of course, each workload may require different configuration combination of the features. The other thing is that if you have a code developed locally, you can actually easily migrate it to the cloud. You don't need to do a lot of change. This is simply how to use SMTP. You just add SMT as a step, part of your neural network defined here in a Python function, and you define what kind of parallelism you want to have. Is it distributed or a tensor parallelism? Then you define your hyperparameters. So pipeline parallel degree, tensor parallel degree. Of course, if you want to have both of them, the number should be bigger than 1. If you want to have a tensor parallel degree, it should be bigger than 1, but tensor parallel degree should be 1, or vice versa. And of course, you are here telling the how many processes per host you have. Processes per host are a number of GPUs available for you to do the trainings, and how you are trying to do the distribution in this case with a model parallel. So that's the only piece of code you need to actually take a neural network model you have developed on a single hardware and single GPU to actually make it a parallel distribution with a distributed training. So talking a bit about our journey, as I said, GPT-J model is an open source alternative to OpenAI GPT-3, mainly used for predicting next token. So it means that you write the sentences, it actually predicts the next step on your sentences. And model is this open source is released by Uthrai. It's based on a mesh transformer AX and trained on the pile. Can perform various. The good news about this democratization of NLP is, before, if I had a use case or a classification or a regression, I had to train a model from scratch. But now, with this big model, we don't actually change much. We can take one of these models. We are just changing our input and our output. We can adapt same model to multiple tasks. We can have a same neural network with a bit of change to actually have summarized text for you, write a story, or even classify text for you as a negative, positive, or emotions in the text for you. So I'm not going too much detail about the training and model serving, but as you know, for training, you need more than 200 gigabytes of memory. And for model serving that you can make a prediction, you need almost around 60 gigabytes. And that's an issue. So if you are doing a training, so you need to really get a distributed training. Okay, I'm just doing that. Yeah, so this is MontyMai. They is a startup, generate startup idea based on a keyword using GPT-J. So you just type home decor, it just creates a startup idea for you to build a startup business. In this case, you can build a web application to help user choose home decoration and accessories. Probably not an amazing idea, but it can help you with that. So our journey is that when we have auto-partitioning and pipeline parallelism and PyTorch data parallelism with the configurations on P316X large, which has 8 GPUs for 800 NVIDIA 800 Tensor Core GPUs at the FP32, we trained a model like that, and it said, nope, we are out of memory, you cannot do that. We tried with a CPU, with a tracing device, nope, you cannot do that because you are running out of memory. Then we tried with a 4-node, and then multiple GPUs, then we were successful. But being successful in itself is not enough. Of course, we have all other parameters turned off, like activation checkpoint and activation loading to free up memory for us. We noticed that jumpstart, just to start the training, takes 4 minutes. After this 4 minutes, you need to download the model from Hugging Face. It takes 10 minutes. That's a lot of overhead. And then tracing and auto-partitioning takes 30 minutes. This is using CPU as a tracing device. It actually takes 18 minutes for the training time. So we have like 2/3 of the time, which we can optimize, which is not the training time during for distributed training. Yeah. So what we did next, we actually turned on activation checkpoint and activation of loading to offload the activation computation during forward pass and calculated during the backward pass of the in the model. We reduced the training time by 6 minutes in this case, just turning on activation checkpoint and activation of loading with the same configuration and the previous one I showed you. But in this case, what we noticed that is if you have seen the model location was from Hugging Face, but we are moved we moved the downloading of the model location to S3 from Hugging Face. It actually improved the model by 10 minutes. You did not need 10 minutes anymore to download the resources from Hugging Face to start your training. Okay, and of course with the pipeline parallel of 16. Now we switch it from P3, which is a previous version of GPUs, to a newer version of GPU 800s, NVIDIA 800 Tensor cores. We actually reduce the training time further by 17 minutes and having a micro batch of 4 and mini batch of 4. So in this case, we have a pipeline parallel, which partitioned the training for us on 8 GPUs and reduce the training time by 25. So P4D 24x large is a new training instances offered by AWS, which actually gives customers 60% less cost time and 30% faster training time. Okay. Now, if we are changing the precision of the computation from 32 floating point to 16 floating point, we actually notice that the training goes down from 25 minutes to 10 minutes. That's reducing almost 80% of the training time and billable time to the customers that the instances are running and they need to charge. So to optimize that furthermore, that in one run, we have 1,600 samples calculated. So if you are having 100 steps, that will result in 160,000, if my calculations are right. Of course, tensor parallelism is in this case is on. We turned off the pipeline parallelism. By on and off, it means that if you recall a bit earlier, I said pipeline parallelism, if it's equal to 1, it means that it's off. It's bigger than 1, that's on. In this case, with the tensor parallelism is bigger than 1, that's why tensor parallelism is turned on in this case. And now, if you look at the first slide I showed you, it was like 10 minute, 20 minute, 30 minute, 10 minute. Now, the whole pipeline for the training of GPT-J on AWS with the Amazon SageMaker tensor distributed training library, it actually reduced to 11 minutes in total, in 10 minutes, less than a minute. So that's a huge improvement for the training time for building distributed training models with Amazon SageMaker. Okay. Now, what are the best practices? So when training large model, try to follow the following step in order to tell your model and fits in GPU memories with a reasonable batch size. So because this is very important how we are doing it, which parameter we turn on and when, that will impact the training time. So in this case, having a GPU memory with a high bandwidth interconnect, for example, P3, P3DN, that's help with the training time. Have optimizer state sharding. This is a case, for example, if you are using Adam Optimizer, you can have a sharding of your optimizers. Turn on activation checkpoint and activation offloading. These are the processes actually to offload your activations from your model and calculate it back during the backward pass, or remove it from the batches which are not active in the CPU. And when you do have a backward pass in the model, then bring them back so that the model can use it. And enable tensor parallelism. In this case, as we saw, tensor parallelism works better than pipeline parallelism because it depends how we are. If you have a high interbandwidth like P3, DN, and P4, we actually have a benefit not to split by layers because we have idle time. We can split by the tensor so that one layer can be distributed across multiple GPUs. Yeah, that's part. And the good news is that the Hugging Face models that currently you can train it on AWS with a distributed training library. is GPT-2, BERT, Roberta, and GPT-J, which is a new addition to the our SageMaker deep learning containers. So you are just pointing to the container, and a lot of these things I talked about is already set up for you to make the development time much faster. So now there is a lot of things I said it, and how I can choose what is right. That's this way. If you have a model size and your batch size, they are bigger and they cannot fit in a single device memory, then if it doesn't fit there, then you need a large training data set. If that's a yes, then you can evaluate data parallel. So if your model is not big, but your data is big, leverage data parallel. But if your model is big, then you need to look at the PyTorch feature that supports SMP, SageMaker model parallel. If it's not there, PyTorch natively doesn't support that, then you can go further. If PyTorch supported, then go there. If it's not, feed the model with the SMP optimizer and have activation or state optimizer, state sharding optimizer checkpoint. If it's yes, then use SMP. If it's no, look at the tensor parallel. If the model parallel is not there, and try parallel without any code change. If that's not the case, then it can be a model or part can be supported by SMP. If that's the case, use SMP tensor parallel and for distributed model implementation. But if the answer is no, let us know. Contact AWS, contact our SageMaker team. We will happy to open a feature request and work on it so that we can integrate it back into our library so that we can support more and more features in the future. So I will be showing a demo a bit after this, but this is public. You have 2 notebooks, 2 Python, Jupyter Notebook Python, very familiar for data scientists. You can actually try pipeline parallelism. You can try tensor parallelism. And with that, I will be moving to actually demo to show you how you can easily run that on SageMaker. Let me see that. If I do mirroring, does it break my... Is it all right?
Yes, works fine.
Okay, if it works fine, that's great to hear that. I'm happy. Okay. So if you look at this, I will not dive deep here to see that exactly which line of code it is, but I just want to show the concept because the code is really simple in itself to try out. So as I mentioned that SageMaker, I will be showing pipeline parallelism and tensor parallelism. Of course, this notebook, you see it here, notebook number 1 is a tensor parallelism. So in this case, as you see that, we have a micro batches. We are putting our micro batches into to the GPUs. So generally it is, we are importing the packages, install some packages and bring in the package you needed. We create if you wanted to create a local session. Sorry, let's make sure, yeah. Create a local session, bring the package, you create a SageMaker connections. Maybe I can zoom in so that will be easier to see. Yeah, bring in the packages needed and the SageMaker execution role to give you the access that you needed to access the resources. Then we need to get our training data set. We are downloading our training data set. This data set we are using is a publicly available SST2 data set, which is a data set being compiled and labeled publicly. And in this case, we have our hyperparameters. This is the hyperparameters we are using to train our model, such as learning rate, how fast, how much our model should be updated. We are looking at the checkpoint optimizer, shard optimizer here for each one of them. So if the value is 1 here, is turned on. And as you see here, we have we have a tensor parallel degree of 1 and pipeline parallel degree of 8. So in this case, tensor parallel degree is turned off. Pipeline parallel degree is 8 because I will be training on a machine which has 8 GPUs. That's why I have an 8 machine or 8 distribution. I want to, as you see that here, I say number per process 8, which I tell them I have 8 GPUs, and then please leverage all 8 GPUs to do the training. This is the part of the model that we need to set up. So we need auto partitioning. That's a part of a distributed training library offered by SageMaker that you can actually do auto partitioning for you. So that way it optimizes the way the model training. And we have also offloading activation to offload the activation during forward pass and unload it again during the backward path. And that's it. This is all of it. And then what we do, we just say that, okay, all of that put together, what is said that this is my code. Please use this machine. And this is my SageMaker. This is the parameters I wanted to choose and the providing Python version, Transformer version, PyTorch version. And of course, somewhere to save our data, the model output in the S3 location. That way we train the model, we save the model and its artifact in somewhere safe. With that, we just kick off the training. That's it. One notebook, 100 line, of course. You can actually kick off the distributed training on a SageMaker easily. Now, this is something I run it before because it might take some time. As you see, there is a lot of log here. But you can see that this model can easily be deployed. Now, the interesting part here is that I trained the model, but how people can use it? Because I have seen in the last 10 years, you have probably heard of it, in the last 10 years, people do a lot of model training. But the big problem was how to bring this model to life that you can use it in your business. And SageMaker help you actually to do that very easily. As you see in this example, I trained this big model. This is my model saved here in a model.tar.gz. And I just say that this is my model. Please take the model from this location and have this permission and packages. Deploy it. That's it. .deploy, nothing else. Now the model is deployed. When it's deployed, what I can do, I just provide the data as an input. I tell them, can you please predict for me? Predict next token for me. So in this case, please know that the results are not great in this because I trained this model only on one epoch, less than 100 steps. A model this big need proper training on a huge amount of data for the business to actually perform good. This is just a demo. So if you see that the result is weird, the model is not ready. It's not ready for production. So if I am saying that, can you please let us know more detail about your, so that way it will predict next token for us, next few words to complete the sentence. Probably this auto-completion, you see it in some application comes from the solution like this. So if I'm clicking this one now, as you see that, probably here it's almost 8 in the evening and can I like go home and rest and watch a film. So that's why I said that the film are good. That's the prediction after that. This way, easily you can deploy the model on SageMaker and use it with an API, make it part of your applications. And at the end, just to make sure that we are not incurring costs, as this is a demo, I will be deleting the whole resources. That way, I don't need to incur additional cost on the instances. I use it for the deployment. With that, I am coming back here and wanted to let you know that as our Global Competency Center professional service, we are hiring all kind of roles. You can check out the tiny link to check out our profile on our jobs. And if you would like to talk with me after that, if you're searching for a job or to talk about what kind of project we work on, or even you want to talk about AWS, feel free to do. Okay.
Great. Thanks for the presentation. Maybe it's time for questions. Let's see if we have some. Okay. Do we have any question from the audience? If not, let's see if we have any questions on the internet. No questions. Okay, so thanks again. Thanks for the great presentation. That was a pleasure that you did that. Thanks a lot.
Thanks for having me.
Before we finish, we have like still a small announcement that we promised. So let's give a second. And yeah, we have some interesting things going on in the AWS community. As you were mentioning on the beginning, that we have a guest here as well from the AWS community, and let's share a few insights.
Yeah, sure. So just a reminder. So you still can fill the survey on the website form. And the first announcement is, Szymon?
Yes, we will have AWS Community Day live in Warsaw in October, on 14th of October. So please go to the website that you see, the awscommunity.pl, and register. So this will be a quite huge event that will be organized by all the AWS community that is placed in different cities in Poland.
We call it community, from community to community.
Exactly. So be sure that you remember the date, and please register for the event.
So this will be the first community day in Poland, in Warsaw. So please subscribe. Another announcement, it's about certification. Always I'm asking the question, have you heard about Global Certification Challenge last year? Anyone? No? Okay.
I heard.
Okay. So let me say some words about this. So about certifications. So currently we have 4 levels of certification. So foundational, professional, associate, and specialty. And thanks to AWS training and certification team, currently we can get free voucher for AWS certification exams. So it's this option is available from May till end of July this year. Who can receive it? It's not public. It's for AWS community active members. And there are some criteria to receive this voucher. So you must be an active user group member, and also 1 voucher for 1 person. Another thing is you need to provide some relevant practice exam passing score. This I'm talking about here about test for a relevant exam level. So you can reach it for free in the Skill Builder AWS site. Everything is for free. Another requirement is if you are active AWS user group community in somehow, you are presenting, you are helping, supporting leaders across Poland. Also, you can reach and fill this form. So if you want, you can just go to this form, fill till end of July, and you can get the 1 voucher for 1 person. Please remember, the voucher will expire after 90 days after receipt. So, any questions? Because that's all. I will leave this for a while, just to take a note, take a screenshot, and also fill a form.
Yeah, fill a form if you want a free voucher for the exam. I think that's it. Thanks again for your presentations and for listening to us. Thanks a lot.
Thank you. See you.